A little bit higher is too uncomfortable for the user. So between the shoulder blades we found was best.
Okay. And so the IMU you had 9 degrees of freedom, right?
Yes.
So did you only use the acceleration? So you only used like the three-axis acceleration? Did you use the gradiometer or the like potentiometer or like anything related to angle or just acceleration?
Um, I wish my the group member that did most of the programming were here. He could probably answer this much better, but I believe we only used acceleration because that's all that we found was really necessary for this. Again, initially we wanted to use two IMUs and compare like relative, one on the pelvis and one on the upper spine. But we found that this solution actually worked fairly well with just using acceleration. Yes.
So you just took the acceleration and changed that into angle, right?
Yes.
Is there a reason why you didn't use the already built-in angular velocity of the accelerometer?
Um, because the accelerometer is not just rotating. It's quite a long lever arm from the base of the spine to the point where we're placing it. So we did take some liberties with approximation there. Um, but if you know the rough length of someone's spine from pelvis to about the base of their neck, then it's fairly accurate to within that 2 degrees with just using the linear acceleration and not angular because of the lever arm of the spine there.
Yeah, but like the question is that so the IMU will already like give you raw data for angular velocity. So if you like specify an axis and then any deviation from that axis, it will give you these angles that you're looking for, similar to what you calculated using the
I I
8
see what
and
you're
2.
saying. So we probably could have had much more accurate data there, in a more simple way. Is
Yeah,
that
is there a reason you don't use that, or you just like wanted to simplify the model as much as possible?
I think that was our real reason is simplification. And again, I wish I could ask who did most of the programming with this section, but I remember us speaking about simplification and what we could get to work with MATLAB was a little bit tricky. And as far as the linear graph that we made, um, what we did seemed to work the best uh, for us. I
Okay.
believe we did try the angular acceleration, and it was we were running into problems with graphing it in MATLAB. We also tried to do a three-dimensional graph, and we found that this method was a lot more intuitive for the user.
Also, do you have a plot? You showed a video of your friend like tilting his back. Is there a MATLAB plot for that?
The friend, no, we actually, so that's another aspect. So currently we didn't have access to you mean the video of my friend right here? Yes.
Yeah, is there a MATLAB plot similar to the one you showed before for this one?
So yeah, that I was gonna bring that up. So we don't have access to a Bluetooth chip for Arduino right now. So we that is something we really wish that we were able to implement, and it should be pretty straightforward. But right now, it only works connected to the laptop. And another solution that we were looking into is using the SD card reader to collect data, and then it wouldn't be real time. But we assumed that real time data would be more useful for this case. Um, so this is the best demonstration we have of it functioning real time.
Okay, and have you ever used an IMU before?
No, this was all of our first time I'm using an IMU.
Is it just you
Um,
or the full team?
I believe one of us had used an IMU before, but not really to this extent. It was a lot more simple.
Okay, you were talking about using two IMUs or like multiple. How do you
Mhm.
think you will be fusing the data from these IMUs to help
Uh,
in accuracy?
yeah, so the idea was place one on, as I said, the base of the pelvis, and the other one would go approximately where the sensor is currently in the upper back between the shoulder blades, and the other would go somewhere in the middle of the spine. And this would more accurately track the real shape of the spinal curve instead of this approximation
Six
that we
minutes
have
is
here.
up. 6 minutes is up. I'll let you finish your thoughts, but maybe take another 10, 15 seconds to wrap up the answer to the question.
Okay. Yeah, so then we would calculate angles between the IMU and just relative to the pelvis, because that is kind of our anchor point, is where it's all relative to pelvis. So if that answers your question.
Okay, yeah, great. Thank you.
All
Thank
right.
you.
Thank you very much for the presentation. Ali, it's up to you. Do you want a quick break to maybe notate some thoughts, or would you prefer to transition to the next team immediately? Typically, we do give like a buffer of a couple of minutes for you to record your thoughts and make notes and write feedback out, but it's up to you.
I'm still scoring on points, so just like 30 seconds,
Yeah, so it's 12:21 right now. I say maybe 12:23. We could
Okay.
start with the next team. Yep, that
Yeah.
sounds good. Thank you. And then just
Thank you,
as a quick
Daniel.
reminder,
Thank
as a
you.
quick reminder, Team 64 is up next. But we'll start at 123, 124 around that. Give some time.
I'm ready whenever Team 64 is.
Hi, can you hear me?
Can you hear us?
Yes.
Yeah, we
Yeah.
are team
Just
64.
before we get started, give me 1 second to reset my stopwatch.
Okay.
I said we'll start at 12:23. So give me 1 second. Okay, it's 12:23 now. Team 64, your time starts now. You have 6 minutes.
So
We need to share a screen.
I also need to share the screen.
You are free to share your screen. Do you not have that permission?
Yeah, I need to set on my computer to share my screen. Well, wait a second. I need to create an can you see my screen now?
No, we cannot see your screen.
Can you see my screen now?
Yes, I could see a screen now.
Now, can you see the PPT side? Now the PPT side.
Yes. I could see a PowerPoint window. Ali, are you able to see it as well?
Yeah, please go ahead.
Okay.
Okay.
I'll excuse the technical difficulties. 6 minutes starting now.
Sure. Hello everyone. We are the team 64. We are making a product called Core Belt. And first of all is our core challenge, which is using wearable device to test core stability. So our goal is to make the device as low cost as possible and as efficient and accurate as possible. So we decided to take on a different approach. Instead of like testing the angle of spine, instead like let the users to perform some movement and test like the stability of the core, like the belt on the stomach, like when the users moves, whether it's like shaking a lot or is very stable.
Yeah. Here is our solution. We would like to build a belt and to use the TUG test, which is an academic way to test core stability. And our method is use a belt and put the IMU inside the belt. Now you cannot see it because we returned the IMU. And then we use the ESP32 to collect the data and use the Bluetooth to send the data to your phone or to other device. And also we create a application which can show you the result of the stability test. And in this page, you can see how we do the connection. We use one ESP32 and use the I2C construct to communicate with the IMU. And also we use the BLE construct to use the Bluetooth to connect with our phone. And in that case, the phone collects the data, the phone will deal with the data and give a result. And also, I use Onshape to create a box to contain all the things. And also, we use toString to build a build. And here is the part of the code from the Arduino. You can see I define the connection, BLE connection, and you cannot see the IMU because it's on another part.
So here's our graphics for the software, and we built it via HTML5 and the WeChat Mini program framework. And the good thing about this is that it's of course cross-platform, so which means it can operate on any operating systems like iOS, Android, HarmonyOS, or even like laptop systems like Windows or macOS. And as you see on this graphic, you can see like there's a little graph in the middle. The blue side means the user is very stable, and the red side means the user is very unstable. And when the test starts, the bar will moving like left or right based on the user's stability. And also, when the user first opens this app, it will automatically connect to the Bluetooth device that we had. Okay, so here's our testing procedure. So we perform a timeout and go test. While when the user starts, we hit the start button, and when the user stops, we hit the stop button. So basically what the timeout and go test means is that users stand up from a chair and walk forward for 3 meters and turn 180 degrees back and walk 3 meters back and then sit on the chair. So during this process, we have like the program like keep tracking of the average acceleration that is not relevant to the moving direction, which it means like when you're walking forward, where does not take into account of the acceleration that is moving the people like forward or backward. So we're only calculating the acceleration like up, down, and left and right. So we have like this average acceleration shown on the screen that indicates the results from our test. And here are some demos. I think I can play this video. So that's like how the users interact with this device. And this video, that's how the app will show when the user is performing the test. You can see it already starts test. And once you hit stop, it should stop. Yeah. I think you have anything to that? I think that's the end of our presentation.
Yeah, this is our presentation. We'll finish our presentation now.
Okay. That was just under 6 minutes. That was actually 4 minutes and 54 seconds. I say it's fine to transition directly into the 6-minute question and answer. So I'm going to start the 6 minutes. Ali, please go ahead.
Very nice approach. I like it. I just have a couple of questions. First, you said you only calculated the acceleration of like turning and bending and not the ones you moving forward or backward, right?
Yeah.
Yeah.
How were you able to isolate the rotational acceleration from like the linear acceleration? So
Sorry?
how are you able to identify that this acceleration is from bending like forward and backward, and it's different from like moving forward and like,
Yeah.
you know?
Actually, in the Arduino, I can show you. Oh, sorry, I cannot show you on Arduino. Arduino, I can use to use one function to get only the x direction and the y direction's acceleration. And also, I set a time like every 50 milliseconds, I will send a message to the phone, and the phone will collect this data and deal with this data. The phone will combine the acceleration and y acceleration by using another method, because for the bar, we need to set it into 100%. And in that case, we need to transform the acceleration to a percentage to showing the complete the application. Can you understand it?
So what you used, you only used the 3-axis accelerometer from the IMU. You did not use the 3-axis like angular velocity, right?
Yeah, I do not use the angle or other other MU data. I only
So
use
you just used, okay. And why did you like this process of like what in the video you showed? Is there a reason why you chose this, like not like sitting and turning or whatever? So
yeah.
is there a reason you chose this specific type of motion for core stability?
Yeah, this way is a way we found is an academic way to test the stable to test the core stability. Like it asks people to stand up and go walk in front and then go back and sit down. And in that case, the shape move of your acceleration of change moving will show that you are not stable. But if you move really smooth, it shows you are very your core stability is good.
Yeah, so we don't want like users to do whatever procedure they want. So we want to set up a standard for all the people to do the same thing. And we choose this test because it first have like the motion of walking forward, and it also contains a motion of like turning and still walking. So we think like this procedure will be well suited for our task.
Okay, and can you go back to the image of the device?
Device, okay. Okay.
So where is the IMU?
IMU is just downside of this paper.
On the bottom?
Yeah, on the bottom, because we need to
Uh,
fix it to the we don't want it move every time.
okay, and is it facing towards the human body or to the other side? The IMU.
Just downstairs below the paper, like the paper on the
Yeah,
left.
so when you put it on the body, is the IMU towards the human body or like to the other side when you wear it?
So
Like
I
in the
don't
video,
use
can you go
that.
to the person moving?
Yeah, go to the person moving. Okay.
So the IMU, is it facing him or facing like the other side?
I think it's facing outwards.
Okay. Uh, did you use an IMU before?
No.
It's our first time using it.
Yeah.
Okay. And what about the Bluetooth device and creating an application?
It's also our first time to create the
Yeah.
application and use the BLE construct to connect between the ESP32 and the application.
So you would say everything you did, you started from scratch, right?
Yeah, we start everything from scratch.
Okay. Very good. Okay. Thank you.
Thank you.
Thank you.
Okay, that was just around 4 minutes and 30 seconds for the judging Q&A. So it's 12:33 right now, or it's about to be 12:34. So maybe 12:36. The other team can be on deck. Ali, just take the time to record and then let me know when you're ready. But yeah, 12:36 around the time we'll get started with the next team. Thank you.
I'm ready at 12:36 whenever team 66 is.
Okay, all right. The final team, Team 66, are you ready?
Yeah, we're ready. I can just share my screen right now. You
Yeah.
guys can hear me fine, right?
Yes, I can hear you. Yeah, I do not see your screen though.
Can you see now?
Yeah, yeah, it just loaded. So is everyone on the team ready?
Yeah, yeah. Everyone on the team is
Okay.
ready right now.
Team, your time starts now, 6 minutes.
All right, perfect. So my name is Shivan Alapati. I'll let the other team members introduce themselves as well.
I'm Jay Benoit.
I'm Arnav Rajashekara.
All right, and I'm Akshat Kotwala.
Right. So we worked on the core stability indicator as well, along with everybody else. And just to give a general overview of what we did before we kind of get into the specifics of both the hardware and the software side, we essentially used both the tilt angle and the acceleration to find exactly when a person's core is actually stabilized. To give a little bit more information to alert the user whether or not there is stability within their core. We used a green light, a yellow light, and a red light to indicate whether or not their core is too extreme or too not extreme, essentially. Basically, the green light would give the base case. It would essentially just show that the core is stabilized, the posture is good, whatever it is. And then the yellow light would give sort of a warning that they're getting a little bit towards the extreme side and that they need to fix whatever it is they need to fix. And then, of course, the red light is just the most extreme example where the user would the user would need to stabilize their core sort of immediately. And that's basically just the general overview. I'm going to pass it on to Jay to talk a little bit more about the hardware side of things.
So for a general overview of the hardware, we used very simple parts. We used the Arduino Nano 3 with SparkFun IMU breakout board, simple breadboard, and as Shiva said before, 3 different LED lights. And for those lights, we use a resistor as well. As you can probably tell, our design doesn't seem too portable at first, but due to some issues we experienced with the LilyPad Arduino, we had to resort to using a normal Nano 3 and not even making it portable. However, the combination of these parts show better results than I think we would have gotten with the portable Arduino.
Yeah, so our initial approach was to use 3 different LilyPad Arduinos. And wait, Shiv, if you could go back a slide real quick. We were going to use 3 LilyPad Arduinos connected by Bluetooth to our computer, and one would go in each pocket, which would help sense the pelvic region. And then one would go kind of like the first team did in between the shoulder blades on the top of the back in order to sense more accurate shifts in the angle. And we weren't able to do this, like Jay said, unfortunately, because of issues with the LilyPad Arduino, but we were able to make a working prototype that combines a shift in tilt angle and a shift in overall acceleration using acceleration in the 3 planes to measure shift in core stability. And the nice part about our design is that it measures the shift irrespective of how you position the Arduino. So it is very practical, the design that we would make in the future, because you can literally just put it in your pocket. You don't really need to align it very well because it measures the tilt angle changing respective to the initial starting position rather than the position to which you have to put it on, or like what you would consider like good core stability, because we're assuming that we're like this is an everyday device for people that would generally have good posture and want to like maintain that good posture, and just want to be alerted if they're having bad posture. Of course, like if you have like for medical things like scoliosis, all of those kind of like diseases, you could adjust that to have it transmit with respect to a position in which you started in. But our design right now transmits respective to like whatever position it's in, so it measures like a change and not you know you don't have to like set it up perfectly. Shiv, if you could go into the demo. So right now, we're trying to like simulate good movement. And so it's in the green light, and then that would be yellow. And then if you tilt too much, it goes into the red. And so it's transmitting the data in real time. And so the user can be alerted pretty quickly as to whether their posture is changing and whether or not they need to adjust their posture. And so in the future, we would, as I said, use 3 different sensors, all kind of using the same kind of methodology with combining the tilt axis as well as the overall stability in order to corroborate results across sensors and make sure that we're getting the best possible results, as opposed to just one sensor that could be faulty. And we took a bit like with the numbers as to like what determines green light versus yellow light versus red light. We found a couple of benchmarks online with regards to tilt angle change as well as overall acceleration. And we fiddled with those a bit until we got, kind of a benchmark that we could work with, that we kind of could visualize as being in the green light versus the yellow light as the red light. We found that maybe the benchmarks online didn't work, because there was imprecision with the sensors, or imprecision with how we're measuring the code. But for the numbers that we ended up using, the functionality worked the way that we wanted it to.
And thank you for
All right, time's up.
clarification.
Time's up. 6 minutes. Now we'll transition to the judging Q&A. Ollie, your 6 minutes starts right now. 6 minutes go.
Thank you for the presentation. So first, your device only works via an Ethernet cable to the laptop, right?
As of right now, yes. We tried to get it to use Bluetooth at first, but unfortunately there were no like Bluetooth Arduinos. That was our initial thought process. We kind of mapped out what we wanted to do before we actually started using parts, but unfortunately when we went to use parts, there weren't any Bluetooth capabilities. So we had to resolve to just making a prototype, honestly. This isn't what we want our final final piece to be. Regardless, we would either miniaturize it by using a smaller, more portable breadboard, or just completely change the LilyPad Arduino. Online, we found there's like a LilyPad Arduino with an adapter that you could just connect the IMU to directly. And so, like ideally, we would want to use like 3 of those. But yeah. So what we made for this is can just be considered a prototype.
So is that the only reason why the device is not portable?
Yeah,
Not
that's
having a
the only
Bluetooth
reason.
device?
Yeah. We were like we kind of disregarded the portability aspect for now, because we figured that without like our LilyPad Arduinos or like a Bluetooth Arduino, there really wasn't a way to do it. So what we wanted to focus on was just getting full functionality, and then in the future what we wanted to do was just miniaturize it, because now that we know that we have the full functionality, miniaturizing it is the easy part.
Also, you mentioned that it's like the axis of the accelerometer or the IMU is adaptive, in a sense that it will like regulate and like reset depending on the starting position of the user, right?
Yeah.
So it's like you remove the bias, it's not like it resets whenever you want it to. So how did you do that? How do you make it like starts as it doesn't use like a reference axis, like it doesn't stick to a reference axis. It like adapts to whenever the user wants it to start from. How did you do that?
So we use the formula online. So we're assuming that XY is just like the flat plane, and then the Z plane is vertical. So, and then when we ran tests, that was confirmed. And so what we did is, to measure the variability of the angular tilt, we took the cosine of the Z acceleration that we were getting and divided it by the overall acceleration, or the inverse cosine, sorry. And then that would that was a formula that we found online, and we used that would give us the angular variability relative to the position that you start it in. So like if you just put it in your pocket, whatever position it takes in your pocket, you don't really have to like make sure it's like stuck to like your quad or something. You can just like put it in your pocket, start the device, and then whatever position it starts in, it'll measure like relative to that starting position. And same with the other IMU that we would put in the other pocket. So they measure data relative to their own starting position, and then that data can be simplified and corroborated with each other. So it makes using like dealing with the numbers a little easier, because you don't need to adjust for how you set up the device.
Won't it be subject to unwanted jittering and movement if placed in the pocket?
How do you mean?
So if I place something in my pocket, it's gonna be loose, and most of the movements, like let's say walking, will be induced not just because of my core stability, not like because like looseness in the pocket, the device being in there, right?
Yeah, okay. So that's one of the things we wanted to use as well, because we didn't want it to just be for medical purposes, although it could be adjusted for that. We want it to be like more of a practical thing for like everyday people to use, like measure with their posture. So we wanted to take into account like people like going for like running, weightlifting, just like walking, everyday movement in general. So that's why we also use the total acceleration of the device in conjunction with the tilt variability. Because like for example, if a person's just walking or running, their acceleration might be a little higher, but their tilt variability might be on the lower side. So we took into account like all these different cases that we could think of, and it was just kind of like a massive switch case for the lights. Like if you're like running, like your acceleration might be high, but your tilt axis doesn't necessarily need to be as high. But so high acceleration doesn't necessarily on its own indicate poor core stability. It would have to be taken in conjunction with these other factors. And then in the future, we could implement like more variables like um, uh, magnetometers or things of that nature to
Yeah,
better
I
help.
agree about the acceleration thing, but still the tilting. Let's say I place like a coin in my pocket right now.
Mhm.
It might like if I take a small step forward, it might actually tilt even though I did not tilt. So like I agree with you about using it for practical and like daily life activity. That's a nice idea. But I think you doing that comes at the cost, which is the device will not be able to be like what they call it, like clinically approved, because there will be tilting not from the human body just because the device is placed loosely in the pocket. If you see what I'm saying? So it can give you like general like tilting or general acceleration, but not very accurate, like medically accurate, I would say, or like to assess the health, because most of the tilting is not actually for the human body tilting. Let's say I place an IMU that's like 1 centimeter by 1 centimeter in my pocket. Like most of the tilting and the acceleration of the IMU is gonna be just because it's not like stuck to something. You see what I'm saying? Like a
Uh,
belt or like taped
time
or
is
whatever.
up. Time is up. Ali, please go ahead and finish your thought.
Okay, yeah, I just wanted to say that I like the idea of everyday use, but maybe for future references or future work, uh, but just consider unwanted movement induced by displacement of the IMU of the or the device in the pockets. That's it. Thank you for your presentation.
Okay, thank you very much. Now let's just quickly go over some logistics. So, Ali, I would request from you. I don't know if you attended the general judging overview or not, or I don't know what information has been given to you since you are a challenge judge and not a general judge, and I'm not entirely sure on my end, so I apologize for a little bit of that confusion. But I think what I'd like to ask is, could you please give like a written justification? First, rank the teams, and then give a written justification for the ranking of each teams, and then you could send that to me by 2 p.m. I will give you my email. I will give you my contact information, but that's what I ask from you. In addition to that, I would also like to ask you to please write some written feedback to each of the teams, maybe specific improvements for the future, or like maybe some suggestions that could be used, like design decisions that could have been made a little bit better. Right, you're the expert in this field, so maybe if you give those three things: the ranking to me, the justification, the written justification for each of the rankings, and then finally the written feedback to the team. So if I can get those three pieces by 2 p.m., that would be good. And I'll give you my contact information before this call ends.
Should I attach my challenge rubric or just like tell you the feedback manually?
The challenge rubric is good. If you have an explicit rubric that's there and you've been working on that, that's also fine. Yeah, that's good. Any information that you have.
Okay.
Yeah. And then just a couple of general announcements to the teams. So the parts, we asked for them back, but since you were the only three teams to submit for the challenge, I will go ahead and say that you are free to keep them until the April 1st Human-Centered Computing Workshop. So it was written in the challenge document that the top three teams will be able to present between noon and 1 p.m. at the Human-Centered Computing Workshop. This is an event to kind of celebrate and kind of explore this new research initiative at Ohio State. So all three teams are invited. I would like to ask though, are any teams right up front not planning to attend that April 1st Human-Centered Computing Workshop to present and to just share what they made at the MakeOHi? It's from noon to 1 p.m. on April 1st. It is a Monday. Okay, so no, I hear no objection. So you're free to keep the parts till that date, and I will be in contact with you with more detailed information about how to participate in that. And then for the teams that did not submit, I will be following up with them directly, individually to collect those parts. Because those parts we do ask for them back. Then when I say parts, I only refer to the parts that were given in that silver bag at the start of the event. The general kits that were distributed to all the participants, you are free to keep those. The team is free to keep those. But we ask for everything that was given in that silver bag back. So just put that on your radar. As a general thing, the Human-Centered Computing Workshop, I will drop the website inside the Zoom chat if you want to take a look. It's very general right now since it's a very new research initiative, but it has some general information about the workshop and then maybe some of the high-level goals of the research initiative. So I'm going to put that link in the chat right now. And then I just like to take a second and then thank the teams for creating and working really hard this weekend. And then thank you, Ali, of course, for being a mentor and then now judging these teams and providing that valuable feedback. So with that, are there any questions from you, Ali, or the rest of the presenting teams?
I'm good, and thank you all for your hard work. The presentations were very nice, and thank you.
Okay, that sounds good. Ali, I will put my email in the chat. And then by 2 p.m., if you could give me the written justification, the ranking, and then you said you had the rubric. So if you had that filled out, that's great. And then written feedback to the teams. And then I will take care, I'll pass it to my team. And then we'll email or we'll send in the Discord. I'm not sure which one. You'll send all the feedback from you, Ali, to the teams directly that way. So that's all I have. My email is in the chat now.
I'll send it right away.
Okay, yeah, take your time, but yeah, by 2 p.m. anything is good. And then we should be good. No final questions, correct? Are we all good from the teams particularly?
I'm good. Thank you.
Yep, you're welcome.
Thank you. We are good.
You're welcome.
Thank you.
Thank
Okay.
you.
Thank you.
Yep. With that, I will be dropping off the Zoom personally. I don't need to stay here. And thank you again, and then I'll leave by 2 p.m. Great. Thank you very much, and bye.